How's it going?
I just came from the eye doctor.
Oh, how'd it go?
And they told me that I couldn't see well from my left eye. I saw less words from the chart in this one than in my right eye.
Really?
Yeah.
I wonder how that even happens. Like, I thought your eyes were like the same.
I asked him too. You know what we should do? I want to test this out because I'm suspicious about this.
Yeah? You want to run a test?
Yes, let's do it.
All right.
Let's see if people can see better from their left or their right eye. We'll have to use the same tool.
All right.
All right, sounds good.
Outside of Langston, there is people gathered to watch and pet puppies. So we decided to get a doctor eye chart, or whatever that's called, and we asked 10 people to cover one eye and then read the letters, and afterwards we told them to do the same with the other eye. And then we collected the data, and this is what we found.
Okay.
Now that we have our data set, we should make a test.
All right. What test should we use to figure out?
We should use the Mann-Whitney one.
Are you sure?
Yeah. Why?
But I don't think we could use the Mann-Whitney because you only use it when you have two different groups of participants performing both conditions, and we only use the same people using both conditions. So we can't use that test.
Which one do you think we should use?
The Wilcoxon test. That should work.
Really?
Yes.
Okay. Let's go with that one.
All right. Okay. So the reason we're using the Wilcoxon test is that we're using the same participants of both conditions for our study, and the data doesn't meet the requirements for it to be parametric, so that's why we have to use it. Okay. So do you know how to start it?
We should look for the difference between each one.
Good point. Let's do that. Okay. So the way we found the difference was that we subtracted condition number 1 from condition number 2, negative 5. So doing that all the way is what we get. After, we need to rank the differences. So, for example, we have our 1, which is going to be our 1. And then we have 2 2s. The way we're going to solve this is we're going to add the ranking that 2 and 2 would get, because it should be like 1, 2, 3. It's going to be this ranking 2 and 3 because they're the same. But we can't give them that rank, so we're going to add 2 and 3 and get 5. We're going to divide it by 2, and then we're going to get 2.5. And so for these two rankings, it's going to be 2.5, 2.5. So we get 1, 2.5, 2.5. And then the next one, next number closest to that is negative 3. Well, 3. We're going to ignore the negatives. But since we've already used 1, 2, and 3, this is going to be 4. We can't use this as rank number 3, and so on and so forth. Now what we're going to do is we're going to add up the positives and the negatives. So negative 5 and 6, 6 and 7, this one and this one. We're going to add up, this one too, thank you. We're going to add up these. And then we're going to also, so the negative, that belongs to negative, and then the ones that belong to the positives. Okay, so now we found our negative rank and our positive rank. We're going to choose whichever rank has the smallest number, and our positive rank, which is 23, is the smallest. So in order to check if there is a significant difference between the left and the right eye within the same group of people, we're going to have to use the Wilcoxon test. And the way we need to use that is that we need to find n first. N isn't your typical n the way you find n is basically the number of participants minus the types of zero differences emitted. Since we have 0 differences emitting, meaning that we don't have a 0 in here, our n is just going to be 10. Because typically, if we have 1 0 difference emitting, you do the number minus 1. But we don't have any. So our n stays as 10, and that's the number of participants. And our significance is 0.05, and we have a 2-tailed test. And so now we need to find the critical value. And like I said, we're going to use the Wilcoxon test to do that. Once we find our critical value, after looking at the test, we're going to see if the rank exceeds the critical value. If it does, then there is no significance. So I went ahead and I looked already at the critical values and the Wilcoxon test, and I found out that it is, in fact, 10.
8. Since our smallest rank, which is our W, is bigger than our critical value, there is a significance difference in seeing between the left and right eye.
So there's a significance. I am probably going to go blind soon. So I'm excited for that. Yeah.